That's good. I like that. Siding towards the upper part of being okay with what's going on. And to answer your question, yes, we will have a Chapter 4 test this week. At the end of class, we'll decide on when it's going to be. So on this one, it gives you the second derivative. You need to find the first derivative. You need to find the first derivative, right? It did? There we go. Is that better? Yeah, it's the cord. Okay, so what do you need to do first? Find the first derivative, yeah. And that's going to be, 8, not 12. Ooh, I did that wrong. 8x cubed plus x squared plus 10x plus what? C. And it tells you that f prime of 1 is -3. So -3 is equal to 8 times 1 cubed plus 1 squared plus 10 times 1 plus c. So what does c come out to be? -3 minus 8 minus 1 minus 10. What's that going to be? -22. So you now know that f prime of x is equal to what? 8x cubed plus x squared plus 10x minus 22. So now what do? Find f. F of x is equal to 2x to the 4th plus 1/3 x cubed plus 5x squared minus 22x plus, let's say d. I use a different letter just so we can go up the alphabet. That's fine. But you know that f of 1 is 5, so 5 is equal to 2 plus 1/3 plus 5 minus 22 plus d. What does d come out to be? Anybody have it? No one did this? 5 minus 2 minus 1/3 minus 5 plus 22. What's it come out to be, Maddie? Do people agree with that? So what do you end up for f of x? F of x is equal to 2x to the 4th plus 1/3 x squared cubed plus 5x squared minus 22x plus 19 2/3. That's fine. As long as you're clear, you can write it that way. That's fine. You need these values because if you don't have these values, it integrates to an infinite number of possible integrals. What next? Okay, so a car is traveling at 100 kilometers an hour when the driver sees an accident at 80 meters ahead and slams on the brakes. What constant deceleration is required to stop the car in time to avoid a pileup? So essentially what you're doing is finding what constant deceleration do you need to stop after exactly how long? 80 meters. So any better acceleration would mean you stop before that. So what does it take to stop in exactly 80 meters? So let's see what we have here. We have this. The distance is 80 meters, right? And at time equals 0. At the start time here, it's going, what, 100 kilometers an hour? And we'll call this time stop right here, maybe? We don't know what time stop is. We don't know how long it takes. Does it say anything about how long it takes him to stop? No. What's the speed? 0 kilometers an hour. That's what we know. At time 0, it's 100 kilometers an hour. Let's say the position here, we know the position here is going to be, let's say, the position. So what letter do they use for position in this book? Is it S? I think. S at 0 is what? What's the position at 0? We'll say he's at 0. And S at time stop. How far is he gone? 80. Okay, so I'm just writing down what they've told us so far. That's all we're doing so far. So you know it's going 100 kilometers an hour. So is that the velocity? Is that the position? Is that the acceleration? What is that? Velocity. So you know the velocity in terms of t at, so v of 0 is what? What's the velocity times 0? Nope. Is 100. Right? At time 0, when he sees the accident. We're calling when he sees the accident times 0. So the velocity at 0 is 100 kilometers an hour. Okay. What next? Make equations. We want to find what? To answer this question, what are we trying to find? The what? Deceleration. What constant deceleration is needed? Is that a velocity? Is that a position? Is that an acceleration? Is a what? Acceleration. So we're solving for an acceleration. Do we know what that acceleration is? No, we do not. So let's call the acceleration. What acceleration? What variable do we want to call it? What letter do we want to call it? Let's call it capital A. So we know that the acceleration at time t is going to be constant. It's going to be capital A. Agreed? We don't know what it is. We know the acceleration at time t is going to be its constant A, right? So therefore, if we anti-differentiate this, what's v of t going to be? There's not x, it's plus what? Plus c. But we know that the velocity at time 0 is what? A times 0 plus c, but we know that equals what? 100. So what does c equal? What? 100. Exactly. Okay. So now we know that v of t is equal to what? Our acceleration of t times c plus what? 100. Okay, that's great. So how do we get the position function? Yes. So s of t is equal to what? Someone tell me. Someone new who hasn't spoken. What's it equal, Corey? If I anti-differentiate this, what does it come out to be?
It would be t to the t squared.
Yep, but what goes in front? That's correct. You're going to drop the 2 down.
1/2.
Correct. A over 2. Exactly. Plus what?
100 squared.
Nope. 100.
X.
No, there's no x in here. T.
T.
Plus, we'll call it d. Correct? What is our position at time 0? What did we say our position was at time 0? Was what? No, our position at 0. No, our position at 0 was 0, and our position at time stop was 80. So our position at time 0 was 0. So no, it's going to be 0 plus 100 times 0 plus d. That equals what? 0. Our position at time 0 was what? 0. That's what we said at the beginning. Can you set this equation up so the position is 80 at time 0? Sure. We're not setting it up that way, though. So d is equal to 0. Okay, so we know that s of t is what? A over 2 t squared plus what? 100. So we have now t. Thank you. Yes, t. So what do we now have? We have the velocity function, and we have the... We want to solve for what? No, we're not solving. We're solving for A. We want A. We want A. What information haven't we used yet? We haven't used anything about time stop. We know what's the velocity at time stop. Well, it's t sub s. What is the velocity? It's 0. What's the position at time stop? 80. Now this is where I have to be careful. 80? Is the position really 80? It's not 80. What's our speed written in? What's our velocity? Kilometers an hour. Is it stopping in 80 kilometers? Meters. So we need to make sure we're staying in kilometers, same units. So what's s of time stop going to be? What? Yeah, 0.08. Correct. Okay. Do we have the position and the velocity functions? Do we actually have them written up there? Yeah. So velocity at time 0 at ts is 0. So we know that a times ts plus 100 is what? 0. And we also know that a over 2 times ts squared plus 100 t sub s is equal to what? 0.08. Correct. How many variables do we have? How many equations do we have? So theoretically, what can you solve for? Both of them. You want A, right? So let's take this first one here and isolate. What are we going to isolate from the first one? Let's isolate TS. TS is equal to negative 100 over what? Over A. And then what do we do with this? Plug it in up here, right? So what do we end up with? A over 2 times negative 100 over A squared plus 100 times negative 100 over A equals what? 0.08. What can I factor out of the both things on the left here? I can factor out well, this one turns positive, right? Because it's squared. The other one turns negative, so it's going to be 100 squared times. This a right there becomes squared, but it cancels with one of the a's on the numerator, correct? So what do you end up with? 1 over what? 1 over what? Well, 2a. 2a. We haven't factored out the 2. Minus what? 1 over a equals what? 0.08. Nice. So 100 squared. What else could we factor out of that if we needed to? So 1 over a. So 100 squared over a is equal to 1/2 minus what? 1 equals 0.08. This is just negative 1/2, right? So you multiply by negative 2, and you end up with what? 100 squared over a. Multiply both sides by negative 2, and what do you get? Negative 0.16. So you end up with a is equal to 100 squared over what? 0.16. And what does that equal? Someone do that out on their calculator for me. What does a equal? Is what? AT plus c. But you know that the velocity at time 0 is a times 0 plus c, which is what? 65. So c is 65. So therefore you know that v of t is at plus 65. So therefore s of t is a over 2 t squared plus 65t plus d. But you know that s of 0 is 0, which means that d is 0. So you know that s of t is a over 2 t squared plus 65t. Correct. So now we have the velocity and the acceleration, but now we look at stop. We know the velocity times stop is 0. So we know that the velocity at ts is a times ts plus 65 is 0. And we know that the position at time stop is going to be a over 2 times, what was it? Ts squared plus t. And we know that equals what? 500 over what? 5,280, because you need it in miles. So now you just take these two and solve for ts, right? Solve for a, sorry, solve for a. And you end up with a is equal to what? Negative 20 what? 23,500? 22,300? Is it exactly 22,300? 22,300. And what's the units on this? Miles per hour squared. Now here's the thing. That's a slower deceleration than we had before. Why? We're starting at about the same speed. It's about 65 miles an hour on the first one. But in this case, instead of 80 meters, what 80 meters is roughly at 250 feet. We have 500 feet. 500 feet. So it's going to be less. So the deceleration needs to be negative 22,300 or a number to the right or to the left of that on the number line. If you go to the right, it slows down slower. You want it to slow down faster, right? So it would go to the left. You need like negative 25,000, negative 26,000. It would stop faster. In this case, we found deceleration. So here we go. So if that's our initial acceleration, what's our initial velocity? What's v of t? Plus some constant, right? But the velocity at time 0 is 0, so therefore c is 0. So therefore we know that v of t is 30t squared. Exactly. Great. If that's the velocity, what's the position function? 10t cubed plus some d value, but you know what's the position when it starts? So 0 is equal to d. So therefore s of t is equal to 10t cubed. Keep in mind, though, that these are only true for what? This is the velocity, and this is the position when what? 0 and 3. Exactly. Good. Okay. So now, let's figure out what the velocity is. So after time equals 3, what's the only thing acting upon this particle? Gravity. Correct? Okay, so we know that the acceleration t is negative 9.8 from 3 to what? 3 to 17. That's correct. Okay, so the velocity is what? 9.8, not x. T plus c. Correct? Well, we know. Let's look at this plus c when we integrated it. We integrated it, right? Plus c. We're okay with that? So there's the exact instant the fuel stops, right? This thing has a certain velocity, right? So what is the velocity at 3? Well, that's going to be 30 times 3 squared, correct? So what's that equal to? What? 270, exactly. So we know that this one overlaps for that brief instant right there. So essentially, it's the v of 0 is not 0 in this case. V of 0 is 270. V of 3 is the beginning part of this stage. So what do we know? We know that 270 is equal to negative 9.8. And what time is that? 3 plus what? Plus c. So what does c? What is? I don't like using c here. We already used d. So what are we going to call? Let's call this plus e right here. So what is e going to be equal to right here? What? 299. Yeah. So it's going to be 270 plus 22. 29 point what? 4. Thank you. So what does E equal? 399. Sorry, 299.4. So therefore we know that the velocity, our new velocity for the next stage is what? Negative 9.8 t plus what? 299.4. Yes.
I have a question about that. Is that when you plug in, for example,
So you need to get F here. Find F for me.